Welcome once again to Chemistry Meal. We want to look at some questions on chemical reaction equilibrium. Just a moment, let me take some water. Okay, we can now talk. Yeah, so we have two questions from UTME. This one is from 2002, question number 6, December 2002, question number 10. That's to show you that this question is always there in UTME and also in WAEC. All right, so let's look at the question together, starting with the first example. In the reaction, this reaction now, E reacting with F to produce G and H. It's a reversible reaction. Remember, one of the characteristics of reactions in equilibrium is that they must be what? Reversible. So they say the backward reaction is favored if the concentration of, so what will make the backward reaction to be favored? That's the question. What will make the backward reaction to be what? To be favored. That's what they are asking. And now the factor of interest, you see, this how to answer this question. The factor we are considering is what? Concentration. So the backward reaction will be favored if the concentration of what? So our interest, the factor we are looking at is concentration. So what will now be in your mind is this: what is the effect of concentration on a system that is in equilibrium? Now, as you have that at the back of your mind, the next thing you will put your mind on is, how will I favor the backward reaction using what? Concentration. So if you go back to the effect of concentration that we have looked at, we say that when we increase concentration of reactant, the forward reaction will be what? Favored. And when we decrease concentration of the what? Reactant, the backward reaction will be what? Favored. Increasing the concentration of the reactant will favor what? We favor the forward reaction, while decreasing the concentration of the reactant we favor the what? The backward reaction. So we have seen what we favor the backward reaction, and this question is about favoring the backward reaction. How will concentration favor the backward reaction? And we have seen it is decrease in the concentration of the reactant that will favor the backward reaction. So we looked at this. The reactants are this and this. It's either we decrease this or we decrease this. That's we reduce it. That's the only time the backward reaction will be favored, according to the rule of how concentration affects a system that is in equilibrium. It is decrease in what? Concentration of the reactants that will favor the what? The backward reaction. So we want to favor the backward reaction. That means we will decrease the concentration of the reactants. So we go to the options. They say if E is reduced, and that gives us the answer immediately. But let's analyze the rest. If G is reduced, now G is a product, right? G is a product. Now we didn't say anything about the concentration of the product, but we know that when we increase the concentration of the reactant, the forward reaction will be favored, right? And when forward reaction is favored, it means more products are generated, and that will also lead to increase in the yield of the what? Of the product. So reducing G cannot favor the what? The backward reaction, because G is not a reactant. Yes, it's not. It is decrease in reactants, the concentration of reactant, that favors the what? The backward reaction. So this is not a reactant. So decreasing the concentration of the product will not favor the what? Will not favor the backward reaction, because it is decreasing the concentration of the reactant. Now, when E is increased, E is a reactant, and we know that increasing the concentration of reactant will favor backward reaction. But in this question, we are trying to favor the what? We favor forward reaction. But in this question, we are trying to favor the what? Backward reaction. So when we increase E, which is a reactant, the forward reaction will be favored based on the rule on how concentration affects a system that is in equilibrium. So if we increase E, the forward reaction will be favored. But the question is, how can we favor the what? Backward reaction. Then we'll go to this option. F is increase. F is also a reactant. Increasing reactant will do what? We favor the forward what? Reaction, right? So this is also off, and this is off. So the remaining now is this. E is decrease, or E is reduce. Decreasing concentration of the reactant will favor what? Backward reaction. Decreasing concentration of reactant will favor backward reaction. And E is a reactant. So when we reduce E or decrease E, it will favor the what? The backward reaction. So the correct answer is this. When E is what? Reduce. So decrease in the concentration of the reactant will favor backward reaction. So the question is, the backward reaction is favored if the concentration of the reactant is decreased, right? And what is the reactant here? E and F. So it's either I decrease this or I decrease this, and the only place we have a decrease in the reactant is in option A, when E is decreased. So option A is correct. That's the correct answer to that. Okay, we look at the second example. We have phosphorus pentachloride decomposing to phosphorus trichloride and the what? And chlorine. So this is another equilibrium reaction. They say in the reaction above, a decrease in pressure will do what? Decelerate the reaction, increase the yield of phosphorus trichloride, increase the yield of phosphorus pentachloride, accelerate the reaction. Now, since we are dealing with pressure, what will come to our mind is, how does pressure affect a system in equilibrium? Now let's write this reaction again somewhere here. Let's write the reaction. We have this. We have PCl3 plus chlorine gas. Okay, this is also a gas. So we have this. This is also a gas. Now, we say that when we want to look at effect of pressure, all day we must make sure that at least one of the what species involved, that's the reactant and the product. Now at least one is a gas, and here the three species are all gases. The three species are all gases, so we don't have problem. So now the next thing we look at is to check the moles of gases on both sides. So we have this. I have 1 mole. I have 1 mole. I have 1 mole. This is a gas, 1 mole, 1 mole. If you combine them, you have total of 2 moles. But here, total of 1 mole. Now we said, how does pressure affect the system, a system that is in equilibrium? Increase in pressure, which one will it favor? Decrease in pressure, which one will it favor? So we said that when pressure is increased, it will favor the side with less mole of gas. Less mole of gas. Less mole of gas means less volume of gas. So increase in pressure will favor the side with what? Less mole of gas. But here, what they are talking about is what? A decrease in pressure. So decrease in pressure will favor the side with more moles, higher moles of gas. Higher moles of gas. Increase will favor the side with what? Less moles. So let's check the side with higher moles. Since we are dealing with decrease, decrease will favor the side with what? With less. Decrease in pressure will favor the side with more mole, higher mole. Increase will favor the side with less. Increase will favor the side with less mole of gas. Decrease will favor the side with higher mole of gas. Increase will favor the side with less mole. Decrease will favor the side with higher mole. So since we are dealing with decrease, let's check the side with what? With higher mole. So is it the left hand side or right hand side? The right hand side has higher mole of gas. We have just 1 mole here. We have 2 moles. So which side will be favored? The side that will be favored will be right hand side. So the forward reaction will be favored because it has higher mole, and we are talking about decrease in pressure. Now, if you look at it in the options, we don't have anything like forward reaction being favored or backward reaction being favored. So that's why we must know the meaning of when a side is favored. Now, if a side is favored, there are other meaning. It means the equilibrium position will shift to that side. That means if we favor this side now, the right hand side, it means the equilibrium position will shift to the what? To the right, because this is the side favored because it contains more moles. So it means the equilibrium position will shift to this side. Now it is still not in the option, right? It's not in the option. Now what's the another meaning? Now if the right hand side is favored, it means that the substances there will produce more of them. The yield will increase, right? Any side that is favored, it means the yield of that side will increase. The formation of that side will increase. The production of that side will increase. The amount of substances on that side will increase. More of those quantities on that side will be produced. So now we now check our option. Decelerate reaction. Equilibrium has nothing to do with rate of chemical reaction, so these two are off. It cannot be decelerate, maybe reduce the rate of reaction, or accelerate or increase the rate of reaction. So we are contending with these two. Now which side was favored again? It is this side, and we know why. A decrease in pressure will bring about favoring the side with what? Higher mole. We have just one mole here, we have two moles, so this side is favored. What and what are on this side? We have phosphorus, trichloride, and chlorine. So a decrease in the pressure will increase the yield of this, because this is on this side, and since this side is favored, it means that more of phosphorus trichloride will be formed. That's, we are going to produce more of this because this side has been favored. Now if it is the backward reaction that was favored, that means it will increase the yield of phosphorus pentachloride. Remember, increase in pressure will favor the side with what? With less mole, which is less volume. While decrease in pressure, just like in this question, will favor the side with higher mole, more mole. So that's why this side was favored, because on this side we have more mole. And because this side has been favored, it means we will produce more of this. That's why the answer is option what? Option B. Don't go anywhere. I'm not yet satisfied. We'll come back and look at more examples before we can now go to our group to answer more questions on chemical reaction equilibrium. I love you.